Hello everyone. Now I am going to explain you about how to write a tie-set and cut-set matrix for this given network graph. So first of all, this is a given network. First of all, we have to convert into equivalent network graph. Then we have to able to write down the tie-set and cut-set matrices. So first of all, what do you mean by a graph? So a network graph or graph is nothing but simply replacing the each and every branch element with a simple line segments. So is nothing but a network graph or network topology. So first of all, we have to, before drawing that network graph, first of all, we have to identify the how many number of branches are there here. So here the branches are like resistors R1, R2, R3, R4, R5, R6. So the number of branches are 6 and the number of nodes are the end point of the branch is called as a node. So each branch has a two node pair of nodes. So here this is the node A, B, C, D, and here we have the two voltage source. So we are replacing these voltage source with a simply it's their internal impedance, like by replacing this line with a simply a short circuited one. If there is any current source, we have to make it as open circuited, otherwise we have to make it as short circuited. Now I am drawing this, I am converting this network into a equivalent network graph. So first of all, identify the number of nodes. So this is the equivalent network graph. Okay. So name the nodes as A, B, C, D. So from A to D only one connection is there because we are making this voltage source as short circuited, and here the current direction is also given to the upwards. So this is one, make it as branch 1. Similarly, A to B is another resistor. We are replacing that resistor R2 with a simple line segment R2, and the current direction is given to the towards node B, and make this branch as node branch 2. Okay. Similarly, from B to C only one connection is there, that is branch 4, and the direction is towards C. Similarly, from B to D is the branch 5 is there, so its direction is towards D, so this is branch 5. Again, from C to D only one resistor is there, replace that with a simple line segment, so that is branch 6. Okay, this is the branch 6. Again, here one more voltage source is there, make it as short circuited one. Then from A to C one more branch is there, so simply replace that with a simple line segment. Okay, so make it as this is branch 3. So now we are successfully converted a network into a oriented network graph. So from this network graph we have to identify the tie set matrix as well as cut set matrix. This is the equivalent network graph. Now first of all we'll write the tie set matrix. Okay. So first of all, to write the tie set matrix or cut set matrix, first of all we have to choose any particular tree. Okay, so in this one, so tree means what, which is it's consisting of all number of nodes like 4 nodes, but it does not contain any closed loop one. Okay, so for that purpose I am considering the 4 nodes. I am considering one tree, so which consists of 4 nodes. So here the nodes are A comma B comma C comma D, and I am considering the this tree. Okay, so here this tree is a connected graph, like all nodes are connected. Okay, and it does not contain any closed path. Okay, then we can call it as a tree. So it just makes the, so the branches of the tree are nothing but a twigs. Okay, here the twigs are like, so here the twigs are like 2, and this is 5, and this will be the 6. So here the twigs are denoted by a letter T, so those are 2 comma 5 comma 6. Okay, after drawing the tree we have to identify the how many number of links are there. Links are nothing but the complementary copy of tree, or nothing but the missing parts of the tree. So here the links are always denoted by a letter capital L, and those are denoted by a dotted lines here. So in this given tree, so this one is missing, so we are making it as link 1. Okay, similarly then here the branch 4 is missing, so this is also one more link. Okay, similarly this branch 3 is also one more link. So here the links are simply 1 comma 3 comma 4. So if you add these links to the twigs, then it is going to form a complete network graph. Now here to write down the tie-set matrix, we have to consider the each link, and we have to tie this each link separately to this tree configuration. Then we can able to write down the tie-set matrix. Okay. So I am writing a, so here I am considering a tie set 1. So this tie set 1, we can call it as tie set 1 or fundamental loops. So here basically I am considering a this tree configuration where consists of all number of nodes a comma b comma c comma d, with the twigs are 2, 5, then 6, and here I am tying the one link to this tree configuration. If you tie one link to this tree configuration, this is going to form a one closed loop. So this is going to form a one closed loop. Okay, just to consider this direction. So they make it as, so the current is I1. Here we have to consider the direction of a link. So what is the direction of the link? We have to consider this current as I1, because we are by adding this link only it is going to form one closed loop. So that's why we are tying a link to the remaining twigs. Okay. So this loop 1 or fundamental loop, or this we can call it as tie set 1. Okay, tie set 1, so our fundamental loop 1, so which is of 1 comma 2 comma 5. So here one closed loop is there, means by applying KVL we will get the voltage equation as V1 plus V2 here. Okay, again, so this is the direction of the current, so that will be V5 is equal to 0. Make it as equation 1. Okay, similarly consider the remaining two tie sets. So this is the tie set 2. So here I'm considering the same tree configuration. So here I am taking this as a link. Okay, so this link number is 4. So here the current direction will be also like this. So here one closed loop is formed. So by the application of KVL will get the voltage as V4 plus. So here the direction is the sixth branch direction is in this loop, and it is oriented. So this will be V6. But here see here the fifth branch current direction is towards D. So in this closed loop here the I4 is what? So this is upwards, and here the direction is downwards, means this branch 5 is in this loop, but its direction or its orientation does not coincides with its value. Then we have to take down that value as a -1. So this value will be minus V5 is equal to 0. Okay, make it as equation number 2. Then similarly consider the tie set or loop 3. So this is the loop 3 configuration. So in this one here the link is A to C. So by tying this link, this is going to form one closed loop. So this branch is 3. So its direction is towards 3. Okay. So here by application of KVL we'll get the equations as V3 so here the voltage are V3 plus, so this is the V3 plus V6 minus V5 minus V2 is equal to 0. Make it as equation 3. Now let write the equations in a matrix form. Okay, so here the number of loops are tisets and the number of branches are branch voltages. So here the how many loops we got? 3 loops of the currents of. So here we got the loop current of I1 and loop current of I4 and loop current of I3. So it is I1, I3, I4. So here I1 equation, loop current for loop 1 we are getting V1 plus V2 plus V5. Okay, so here the branches are like 1, 2, 3, 4, 5, 6. So here the equation is V1 plus, so here the equation is V1 plus V2 plus V5. So I1 is V1 positive 1, V2, V5, and these are the not associated voltage, just to make it as 0. Okay, for I3 are, okay, for I3, so we got the 4 voltage, those are V3, V6, minus V5, minus V2. So 1 is not there. Okay, minus V2 means it's mark it as minus 1, then plus V3, then it plus 1, then V4, V5. Then coming to the fourth link, I4 is V4 plus V6 minus V5. So V4 plus V6 minus V5. Okay, so this is the equivalent tiset matrix. So here we have the number of links or number of twigs link. Tiset loops are 3 with the branches are 6. So order of this tiset matrix is 3 by 6. This is the tiset matrix. Now we will see how to write the cut set matrix for same network graph. Okay, so for cut set matrix also, first of all we have to consider the tree configuration. So here I am considering the tree configuration of the same. Okay, so which has a open loop one, which has a 4 nodes A, B, C, D. Okay, so this is the one we are considering. So this is branch 2, this is branch 5, so this is branch 6. But to write down that cut set matrix, first of all we have to consider the what are the links are there. So this is the link and this is the link and this is the link. Okay, so to write down a cut set matrix, the mandatory things we have to consider all the links. Okay, so here the links are like 1, and this is the one more link 4, and this is the link 3. Okay, in this one we have to consider a one twig. Okay, so here I am considering this twig, its number is branch number is 2. Now we have to cut this cut set into equally 2 parts. So here I am cutting this by node, and the direction of this cut set one is simply the direction of your twig. So here the twig is towards B, so that's why I'm considering that I'm cutting that node towards B. Okay, so this is going to form a cut set 1. Okay, so here the cut set 1 we are cutting the branches 1 comma 2 comma 3. Okay, so this will result in a voltages of branch currents. So here the branch 1 is associated with this cut set and is in the slope. So and the direction is opposite to that cut set. So this is towards B, but this is towards A. This is back side means. So here the direction of the that current will be. So cut set 1 we are writing the voltage V1, which is equal to, so the currents are here, minus I1 plus I2. Then here the direction of this branch 3 is towards B only, so this will be I3. Okay, make it as equation 1. So this is a cut set 1. Similarly consider the second cut set. Okay, so second cut set considering 4 nodes A, B, C, D. So here, so these are the links, and these are the links. Okay, in this one now I am considering this twig, so the branch 6 which is towards D. Okay, now cut this graph here into equally 2 parts. Here we'll get in one dilemma, which node we have to cut, either D node or C node. But here when you are cutting this D node, it has only one twig, only one link. But to cut any node for a cut set matrix, we have to cut more number of links with the only one twig. So that's why I'm taking this, I'm cutting this node across C. So this is the cut set 2. So here we are cutting the branches 3, 4, 6. So here the direction of 4 is towards C. So this is the direction. So this will result in a second voltage in terms of current. So here branch 3 is towards C. So that is plus I3, and branch 4 is towards C plus I4. So here when you see here branch 6, so this is in the cut set, in this cut set, but it is direction is towards D, means it's not associated with that, so its direction is minus I6, which is equal to 0. So make it as equation number 2. Then similarly consider the cut set 3. So in this cut set 3, here I am considering this branch 5. So here it has only the one link and one twig. So we can consider this one. So we can cut this node. So this is the cut set 3 of branches 5, 1. So here the resultant currents will be, so 1 is towards A and 5 is towards D. So 1 is nothing but minus I1 plus I5 is equal to 0. Now we have to write down the cut set matrix. So here the number of cut sets are like V2 and V6 and V5. Okay, so it will result in, so here the branch currents are like, how many branches are they? 1, 2, 3, 4, 5, 6. So for first cut set, so we are getting the currents of minus I1 plus I2 plus I3. So this is the branch current, means minus I1 plus I2, sorry, this is plus I3, rest are 0. Similarly coming to the second cut set, so second cut set is I3 plus I4 minus I6. So I3 plus I4 and minus I6 coming to the branch 5, it is minus I1 plus I5. So minus I1 means, and these are plus I5. So here I am writing the cut set matrix denoted by Q of Ij, which is equal to minus 1, 1, 1, 0. So this is I am writing here, so 5 minus 1, 0, 0, 0, 1, 0, and this is the sixth one, 0, 0, 1, 1, 0, minus 1. So here the number of cut sets are 3, the branches are 6. So this is the order of the cut set matrix. Thank you.